part 2 of tangents and normals. In case you haven't seen part 1, then I'll link it for you in the description box, as well as you can press the I button on the top to get the same. And now let's get started. In today's video, we are going to discuss equation of a tangent and equation of a normal. Though we've already discussed the equations in the previous part, so as a quick recap, we say the equation is y minus y naught is equal to m times x minus x naught, where x naught, y naught is the point of contact, by which we mean the point at which the tangent touches the curve, and m happens to be the slope of the tangent, which we covered in part 1 elaborately. Similarly, equation of normal would be y minus y naught equal to minus 1 by m times x minus x naught. Now you know, if slope of the tangent is m, then automatically slope of your normal now becomes minus 1 by m. So if we are good to go, let's begin with the question. It says find the equations of the tangent and normal at the point, and the point has been given this way. Now you might not find any curve directly, but you have done parametric differentiation. If you are not very clear with differentiation, please check out my playlist on the same topic, which covers all types of topics in structured videos. So here, making use of your parametric differentiation, your dy by dx would be dy by dt upon dx by dt, which gives us b into 3 cos square t into minus sin t whole upon a into 3 sin square t into cos t. On simplifying, we get minus b by a into cos t upon sin t. Now please see, in order to find equation of the tangent at this point t, we get equation of the tangent to be y minus y naught, where this acts as the point y naught at t. So y minus y naught is equal to m into x minus x naught, which is once again over here. Now all you need to do is cross multiply and give the final answer. Similarly, coming to equation of the normal, your equation of the normal would be y minus once again y naught is equal to, now in order to get the slope, we would take the negative reciprocal for this, which acts as a by b into sin t upon cos t into x minus x naught, which shall be the same. And once again, you can simplify this to give your final answer. Please note here, t has been a very general point. In place of that, you can get any specific value. For example, if you had to find the equations at the point pi by 4, then wherever you find t, you are going to replace it with pi by 4. Now have a look at the second question here. It says find the equation or the equations of the normal or the normals. Now whenever you see s written in brackets, that simply gives you a little uncertainty as to whether you'll get only one equation or multiple equations. So you need to be very careful. To the given curve, which is or are parallel to the given line. That means we are focusing on equation of a normal which will be parallel to the given line. So let x naught, y naught be the point of contact to begin with. Now when we differentiate this equation, you get 6x minus 2y into dy by dx is 0, which means dy by dx is equal to 3 into x by y. Now we are looking at equation of the normal, so we are interested in getting slope of the normal. So we can say slope of the normal or normals, we would soon realize. So slope of the normal at this point would be the negative reciprocal for this. So you get minus y naught upon 3x naught. Now it's further given that it is parallel to this line. As you can see, the slope of this line will be minus 1 by 3. So according to the question, we get minus y naught upon 3x naught should be equal to slope of this equation, which is minus 1 by 3. On solving, we get 3y naught equal to 3x naught, or in short, y naught is equal to x naught. Once again, in order to find your x naught, y naught, we would use that this point of contact will also satisfy the equation of the given curve. So, we would say since x naught, y naught lies on 3x square minus y square is equal to 8, this implies 3x naught square minus y naught square is equal to 8. Now, let's start putting the value. We get 3x naught square minus x naught square is equal to 8. This means 2x naught square is equal to 8. This gives us x naught as plus or minus 2. So, two cases. Now, if your x naught is 2, then your y naught is also 2 from here. Similarly, when your x naught is minus 2, that makes your y naught also minus 2. Now, to get your equation of normal, we simply say y minus y naught is equal to, now the slope is the same as minus 1 by 3 into x minus 2, and likewise y minus y naught, that makes it plus 2, is equal to minus 1 by 3 into x plus 2. Make sure to cross multiply and give a simplified answer. Let's explore the third question here. It says find equation of the tangent line to this given curve which is perpendicular to the given line. So that means if I first of all get the derivative from here, it becomes 2x minus 2. Let x naught, y naught be the point of contact. You know point of contact is essential. This is x naught, y naught to get any equation. Thus we have slope of the tangent is 2x naught minus 2. Now further it says this tangent is perpendicular to the given line. So if we see the slope of the given line would be 15 by 5, that is 3. So now since the tangent line is perpendicular to this, so according to the question, we get 2x naught minus 2 into 3 should be equal to minus 1. This gives us x naught becomes 5 by 6. Now substituting x naught as 5 by 6 in the given equation, we get 25 by 36 minus 10 by 6 plus 7, which is, so on simplifying this you get 217 by 36. Thus the point of contact is 5 by 6, 217 by 36. Once you get the point of contact, you also know the slope of tangent if you put x naught as 5 by 6. So we can say this gives us m as twice of 5 by 6 minus 2, which is minus 1 by 3. So getting equation of the tangent is very simple now. So you say equation of the tangent will be y minus y naught is equal to m times x minus x naught. Please simplify this till the end. Have a look at the fourth question. Find the equation of the normal to this weird looking curve at the point x equal to 0. So first of all, let's figure out what's the point of contact. If we are already given x equal to 0, my y shall become, this would be 1 raised to power y plus sine inverse of sine square 0. So this would give me sine 0 is anyway 0 and sine inverse of sine 0 simply gives us 0. So y is equal to 1. So now we have the point of contact or our x0, y0 to be 0, 1. Now all you need to do is find the slope of the normal and then use the equation to get the final answer. So in order to get the slope of the normal, let's first find out our dy by dx. But if you look at the first term, it's very weird looking. No, this makes use of your logarithmic differentiation, which you can find either by clicking the I button or by going to the playlist for differentiation. Now, so if I consider this to be y equal to, let's say I call this as u plus v. Now for u, which is 1 plus x whole raised to power y, I take log on both sides to get. Now differentiating both sides with respect to x, you get 1 upon u into du by dx is equal to y into 1 upon 1 plus x plus dy by dx into log of 1 plus x. So we get du by dx to be, if I cross multiply this u and replace it with the original function, into y upon 1 plus x plus log of 1 plus x into dy by dx. Now for v, which happens to be sine inverse of sine square x, this is direct differentiation making use of your chain rule. So dv by dx simply becomes sine inverse of some value would be 1 upon under root of 1 minus x square. So this becomes sine raised to power 4x into sine square x gives us 2 sine x into cos x. Thus, our final dy by dx from here gives us du by dx plus dv by dx, which is 1 plus x whole raised to power y into y upon 1 plus x plus log of 1 plus x into dy by dx plus this makes it sine 2x upon under root of 1 minus sine raised to power 4x. Please remember, this is dy by dx. In order to find your slope, in order to find slope of normal, you have to take the negative reciprocal at this point. Now let's substitute the value of point of contact, which is 0, 1. So our dy by dx gives us, if I replace x with 0, y with 1 everywhere, so our dy by dx becomes 1 from here. This is 1 plus log 1 is 0, so this term vanishes, plus you get 0 again. So dy by dx in short gives us the answer 1. But please remember, dy by dx at point of contact gives us slope of tangent, and we are looking to find the slope of normal. So moving further, slope of your normal would be simply the negative reciprocal of this, and thus equation of the normal becomes y minus y0, the point of contact was 0, 1, is equal to minus 1 times x minus x0. And here obviously once you simplify, you get y plus x minus 1 equal to 0, which is the required equation. So these were the very quick questions on the topic of finding equations of a normal and a tangent. I would very soon see you with part 3, which will be packed with tricky and the sample paper based questions. Until then, do not forget to like and share the video and subscribe to my channel. Bye bye.